In this experiment, we are going to measure the thickness of a thin wire using two methods. One is through the Fraunhofer diffraction, in which we are going to use the diode laser, and then we have to measure the thickness of the wire directly by using the screw gauge. So the apparatus we use is a thin wire and red diode laser source and a screw gauge. So thin wire which I'm going to use, is you can see is very thin wire is there on this stand, and this is my red diode laser. The red beam is coming out from the diode laser, and these are situated as at the bench, where this here we have some scale, and these are the stand. This stand we have my thin wire, and this is my red diode laser. So the diode beam is coming out and is striking the red wire at this position. You can set the red dot, and then there we have a screen on which we have to see the spectrum, the Fraunhofer diffraction spectrum. Basically, let me explain a little bit. Okay, when a laser beam hits a straight wire from a direct perpendicular to the length of the wire, then a series of bright spots are observed on the screen, which we will see right now, whose plane is perpendicular to the direction of the propagation of the laser beam. Since the wave front of the light associated with the laser beam is planar, the diffraction path observed on the screen may be classified as Fraunhofer diffraction, provided the separation between the wire and the screen is at least 1 millimeter. Okay, so the formula which we are going to use to find the thickness of the wire is directly using this, is sine theta n upon n equal to lambda by d, because lambda is the wavelength of the red diode laser, and because this is red, so the value of the wavelength which we are going to use is 6328 angstrom. Okay, and then we have to find the separation between the wire and the screen. Okay, we have to note it down, separation between the wire and the screen. So the wire is placed here at this position, and then we have from this screen to this wire location, this screen which is on the wall, and then the wire which is on this node. We have to find out this difference, which is denoted at x in this experiment. So we are going to use the wavelength 6328 angstrom in this value, and d is and sine theta by n. We have to plot this n is the order of the spectrum. So what we are going to do is the order of the spectrum, and then finally we are going to find the sine theta n, and we have to plot sine theta n and order graph between the sine theta n along the y-axis and n along the x-axis. N will be 1, 2, 3, 4, 5 order of the diffraction, and then it will comes out to be a straight line. So that will give us the slope. The slope will be basically sine theta by n. So it's like if I plot this sine theta n on the y-axis and n on the x-axis, I'm going to get a straight line, and we will find the slope of this line. Okay, so this will be delta sine theta n, and this is delta n. So sine theta by n, this will be the slope. So sine theta by n will be the slope, and we'll put this slope equal to lambda by d, because lambda already we know, so we can find the value of d. That will be the thickness of the wire. So using this experiment, we will find the thickness of the wire using the red diode laser Fraunhofer diffraction, and then we'll directly measure with the help of the screw gauge. Okay, so let us find. So this is my laser beam and red laser beam, okay, which is striking the wire. Switch off the light, and then striking my wire, whose thickness we have to measure, and then on the screen both the lights, and then on the screen you can see we are going to get the spectrum. It's the dark room. You can see here. Okay, so this is my bright spot. Okay, and then we have dark spots. This is then we have a dark spot here, dark spot here, dark spot here. So on this graph paper we have to note down, we have to point it down this dark spot and then the corresponding this white spot and then the dark spot. We have to note it down, the dark spots, wherever the dark spot is here, the upper and the lower side. So you can see this is dark. In these two dark we have a bright spot, so we have to note down the dark spot using the pencil. Okay, so the both side from the dark spot, we have to note down these dark positions. Okay, this is the first part of the experiment. Then after doing this we have to take this graph paper. Now after the spectrum will look like this. This is the brightest spot in the center and these dots are the dark spot, and between these this is the bright one. Okay, so we have to denote it like y1, y2, y3, y4, y6 and so on the right hand side, and the y1 prime, y2 prime, y3 prime on the left hand side. So what we have to measure is like the distance between this bright spot to this location. Okay, this location, this will be y1 and this will be y2, and similarly from here you have to measure the difference of this y2 and then y3 and then y4, and similarly from the central dark spot we have to measure y2, y3 prime, y4 prime. All the distance you have to measure. Like if you can see, the y1 is like from here to here, this is 1 centimeter, or you can write it 10 millimeter or 1 centimeter. Similarly y1 prime and y2, you can see that this is something 19 millimeter or 1.9 centimeter. So I can write for the main scale reading. You can see that in the observation, the order of the diffraction, this is n1 is 1 because this is y1. So y on the right side I can write 1 centimeter or say 10 millimeter or 1 centimeter, whatever choose you write. And similarly on the left scale this is 10 millimeter. Okay, similarly for 2, this is for y2. For n2 I can write from here to here y2, here to here y2 prime. So similarly we have to fill all these columns. Okay, and then we have to find tan theta, that will be y1 plus y1 prime divided by 2x. X is the separation between the wire and the screen, I have already told you. And then find the tan theta, and then you have to find the theta and then sin theta n, and then put the value of sin theta on the y scale and the 1, 2, 3, 4, 5, 6 order of the diffraction on the x-axis, and then find the slope of the system, and then using this formula find the value of d. Okay, so this is the one procedure. The other procedure in which you directly use the screw gauge, and first you have to find the least count of the screw gauge, 0 error, and then using the main scale rating and all these, you have to find the width of the diameter of the scale. And then, because there are two methods you are finding the thickness of the wire. One is the thickness of a wire that you use in the screw gauge, see what it's coming out to be, and then the other laser diffraction procedure. This has to be same, has to be comparable, because the thickness of the wire is going to be same whether I measure with the help of the screw gauge or using the diffraction method with the diode. So this is what we need to do in this experiment of measuring the thickness of the thin wire using the red diode laser and using the screw gauge.